This is the 8.3 exit ticket, where we will be comparing representations of quadratic functions. Number 1, 3 quadratic functions are shown. Which function has the largest positive zero? Explain your reasoning for your choice. So to do this, finding the zeros for each of the functions would be a good strategy. So finding the zeros for f of x, remember a 0 is when y equals 0. It's your x-intercept. So to find that, we need to solve this. Okay, 0 equals x squared plus 7x minus 8. So to do that, you can either factor or you could use the quadratic formula. Here, the factors are pretty simple. Okay, two numbers that multiply to get negative 8 that add to equal positive 7 would be positive 8 and negative 1. Oops, not negative 7, negative 1. Okay, and we can check that out. If we do x plus 8 times x minus 1, we get 8x minus x and negative 8. That does give us that positive 7 and the negative 8. So from here, all I need to do is set my two factors equal to 0. So for x plus 8 equals 0, x would equal negative 8. And here x would equal positive 1. Okay, now it says largest positive 0, so that's all I care about in this sense. I just want to know which one's the positive one. All right, now looking at the graph, okay, we're finding those x-intercepts. Now we have a negative 1 here. Okay, this one's negative. I don't really care about that because I'm only looking for positive. Okay, but it is negative 4 if you wanted to know. Okay, and this one is a positive 2. This one's a positive 2. Okay, so here we have two options already. Now in the table, okay, all you need to do is look for where y is 0. So y is 0 here and here. So that means my graph, when it's crossing at negative 2 and 4 on the x-axis. So my positive 0 is 4. So whichever one is the largest, okay, is going to be my answer. And here we can see that we have 1, 2, and 4. So option, the table, right, n of x has the largest positive 0 because of those reasons we just said. All right, number 2. Which of the functions shown below has a larger maximum value? Larger maximum value. Justify your answer. Okay, so to find the larger maximum value, okay, that's asking for the vertex. Okay, that's asking you wherever that function, whether it's concave up or concave down, it wants, well, these ones are going to be both concave down because it says maximum. Oops. So we want to know what that point is, okay? And remember, you can always find the point, the x value of the vertex, by doing negative b over 2a. We've talked about that. So that's where the axis of symmetry is, and that's also the x value of the vertex. So if we can find that, we can also plug that in to find our y value at the end of the day. So looking at our first equation, we have factored form. But to do the negative b over 2a, it'll be helpful if we can find what this is when we distribute. So we have x plus 3, 5 minus x. You would get 5 times x, 3 times 5, x times negative x squared, and then negative 3x. So that means that j of x, okay, when I combine my like terms, I have a negative x squared, I have 5x minus 3x, which would be 2x, and then I have that positive 15. So my b value is 2, my a value is negative. Remember, that's like a negative 1 there, okay? So when I have negative b over 2a, okay, that'll be b equals 2, a equals negative 1. So we'll have negative 2 over 2 times negative 1, okay, which is negative 2 over negative 2, which equals 1. So when x is 1, that's my vertex. So to find the whole value, okay, because we want the larger maximum value, which is the y value, where is that on the graph at 1? So all you need to do there is go and plug it in. Okay, you can plug it into either equation. It might be easier to go back and plug it into the original one. So x plus 3 times 5 minus x, so we'd have 1 plus 3 times 5 minus 1, so you get 4 times 4, which is 16. Okay, so the vertex for this guy is 1, 16, so that's the point. And now the table is going to be a little bit easier. Okay, so finding a vertex from a table, all you need to do is find, okay, we're looking for a maximum, so the highest y value. So we have negative 7, 0, 5, 8, 9, 8, 5, 0, 7. So we can see that 9 is the highest when it reaches. So that vertex is at 1, 9. So in thinking about j of x or n of x, which one's higher value, we're going to pick j of x. It's at 16, whereas n of x is only at 9. So j of x has the larger max. All right, how do you feel about this exit ticket? Do you have any additional questions for me? Rate yourself on a scale of 1 to 4.